Hello everyone, so today in this video we are going to solve a question on LeetCode. It is minimum cost climbing stairs. This is 446 question on LeetCode and this comes under easy category. Alright, so let's start with the problem statement. You are given an integer array cost where cost I is the cost of ith step on a staircase, right? This is the cost of ith step on a staircase. Once you pay this cost, right? Once you pay this cost, you can either climb to one step or two step, right? You can climb to one step or two step. Then what is given is you can either start from index 0 or 1, right? We have two conditions. We can start from either from 0th index or from 1th index. Now we need to return the minimum cost to reach the top of the flow, right? We need to return the minimum cost. So definitely we're gonna use a recursive function or DP to find out the minimum, because we need to check all the cases in this, right? We need to check all the cases, or we can say all the possibilities and combinations, and we need to find out the minimum out of them, right? So let's see how can we approach this question. So let me just copy this example here, right? And yeah, so what we have to do, like we have given two things, right? We have given two things. The first is we can start from 0th index, right? We can start from 0th index or 1th index, right? These are the two possibilities given to us. And the second thing given to us is we can either climb to one step or two step from this index, like any of the index, right? From the current index we can climb either to one step or two steps, right? And let's say the building is here somewhat, right? Let's say the building is here and we need to climb here somehow, right? So let's see what are the possibilities here, right? So let's see, we start, we have initially we have two possibilities. We have 0th index and 1th index. So we can either start from 0th index, right? And either we can start from 1th index. Let's see, if we start from 0th index from 10, so we will have array something like 10, 15 and 20, right? And if we start from 1th index, then we don't have access to this, right? Then we don't have access to the 0th index, so the array will become 15 and 20, right? Now the second thing is we have just checked both the possibilities for first one. Now the second thing is we can either climb to one step or two step, right? We can either climb to one step or two step from here, right? So let's see both the conditions. So let's say we have, in this condition we can climb to one step or two step, right? Similarly for this we can climb to one step or two step, right? So when we climb to one step we will go 10 to 15, right? And when we climb to two step we will go from 10 to 20, right? So what will happen, this 10 plus 15 will become 25, right? And 20 will remain as it is. Similarly when we climb to two step we will get 30 here, right? And in this case if we climb to one step, right, so we will get 35. And if we climb to two steps, so we will just reach the building, right? So we will be just writing 15 here because the cost is not updated yet, or we can say we don't need any more cost, because with this 15 only we just reached the building here, right? We reached the building here. Let's see what other possibilities, right? So if we have, let's say here we have two conditions, either we can climb to one step or two steps, right? So let's see, if we climb to one step we will get 35, right? And if we climb to two step we will get as it is 25, because we can directly climb it here, right? So now let's see what our answer are here, right? So these are the cost in each cases, right? These are the cost. So we need to return the minimum out of this, right? We need to return the minimum out of this. So minimum out of this is 15, right? The minimum out of this is 15, so we will be returning 15 in this case, right? We will be returning 15 in this case. I hope this recursive tree is clear to you. So to form this recursive tree, the recursive function will take around big O of k to the power n, right, k to the power n time, and we can reduce it further to big O of n, right, we can reduce it further to big O of n by using a memorization in the dp array, so that we don't repeat the sub problems again and again, right? So I hope this is clear to you. Let's quickly see what is the function we can form here, right? So the function could be, let's say the function is cost of n, right, is equal to cost of mm, cost of n plus we can say cost of n is equal to minimum of, right, the minimum of cost of n minus 1 plus cost of n minus 2, right? We can check the previous two here, right? The similar function we will be using in the code, right? So let's quickly move to the coding part. I hope this approach is clear to you. We just need to check the previous two here, right? Or we can also check I plus 1 and I plus 2, right? These also we can check if we start from I equal to 0, right? So let's see the coding part, right? So let's start the dfs function. So before that, let's write a helper function here, int helper, which is basically a recursive call. So in this we will be taking a vector of integers cost, and let's also take a pointer int I, which will be telling us the index, right? And what we need to do is also take a dp array, right, to memorize, because we are directly writing this memorized one, right? Because we already know this recursive won't work here, right? So we will just directly memorize this. So the limit of this is 1000. Let's initialize it with 1001, and the type is int. Let's set all the elements of the dp with 0 initially. So mem set dp 0 and size of dp, right? And now let's call this function here, right, this helper function. So return helper cost, or we can say we need to return the minimum out of them. So let's return minimum of helper cost, and it's 1. Or we can say we have two possibilities, right? We can either start from the 0th index, or the second possibility would be we start from the 1th index. So helper cost 1, right? These are two possibilities here. Now let's write the helper function here. So in the each iteration we will just return let's store this into the dp of I, and this should be equal to cost of I plus minimum of either one jump or two jump, right? So for this we will be calling helper cost I plus 1 for one jump, and second minimum would be helper cost of I plus 2. This is for two jump, or we can say we can climb till 2 height, right? So these are the two jump, and the exit condition for this would be like if this I exceeds to the size of the cost, right? So if I is greater than equal to cost dot size, then we can directly return 0 from here. And to reduce some steps, let's write if dp is already filled, then we don't need to proceed this recursion. So if dp of I does not equal to, let's initialize it with 1 minus 1, right? So if this is not equal to minus 1, then dp of I will be written from here, right? This will be written from here, and this is fine, I guess. Let's just run it. Yeah, it's working fine, and let's just submit this. Yeah, it's working fine. So the time complexity of this solution is big O of n, right? The time complexity and space complexity both are same, so this is equal to big O of n, right? Now let's see how can we further reduce this, right? So we can further reduce this with, let's say we can further reduce this by using Fibonacci type of combination, or we can say the Fibonacci type of series, because in this we are basically checking the last two values, because right, we can just checking the last two values, either we can jump to 1 or 2, so we just need to keep the check of last two values, right? So we can form, or we can say we can just update the given array, right? We can update this in place, we don't need any extra array here. So this space complexity will reduce to big O of 1, right? So let's see that case. So let me just clear this. So what we can do is we can check the previous two one. Let's just see this example, right? So what we were doing is, let me just paste it here. Yeah, so this is our first example, and in this example what we can do, let's say if we start from this index, right? If we start from this index, we can check the previous two ones, right? So if we update this index with the minimum out of this 10 or 15, so this will come out to be 30, right? The minimum is 10, and 10 plus 20 is equal to 30, and we have just completed the equation because we are starting from here, right? So let's see the minimum out of last two values, because the maximum jump we can do is 1 and 2, right? We can maximum jump to 1 and 2. So let's say if we jumped from this 10 to 20 and this 15 to 0, so in this case the minimum would be 15, right? So similarly we can see here that, let's say this is 15 and this is 30, and this is the updated array after iterating from this index till the end of the array, right? So what we can do is, at the end we can just return the minimum out of the last two values, right? So the minimum out of these last two values is equal to 15, so 15 is our correct answer. Let's see the second example. So the second example is this one. Let me just copy it here to here, right? Just paste it here. So this is our second example. Now let's try to implement this approach in this question, in this example, right? So we are just skipping the first two index and starting from this one, right? So let's see, if we start from this, so this one will be updated with the minimum of previous two, right? So minimum of previous two is equal to 1, so 1 plus 1 is equal to 2, right? Now this one is updated with the minimum of previous two, so this will be updated with 2 plus 1 is equal to 3, right? Now this one will be updated with the minimum of 2 and 3, so 2 and 3, the minimum is 2 plus 1 is equal to 3, right? This 100 will be updated with the minimum of 3 and 3, so this will be updated with 3. Now you must be wondering why we are just checking the previous two, right? So we are checking the previous two because we can only jump one step or two step, right? That's why we are checking the previous two, right? Now let's see the cases, like this will become 103. Now this one will be updated with the minimum of 3 and 103, so this will be updated with 3 plus 1 is equal to 4, right? Now this one will be updated with 4 plus 1 5, this 100 will be updated with minimum 4 and 5 is equal to 4, so 104, and this one will be updated with the minimum of 5 and 104, so 5 is minimum. Let's update this one with 1 plus 5 is equal to 6, right? Now at the end we have these two values, right, on the last two indexes, so 104 and 6. So in this case, we will be running the minimum. So minimum is 6, right? This is the minimum. So let's see whether we are correct or not. Yes, we are correct. This is 6. So our approach is working fine. Let's just quickly code it up. Right, so let's take int n is equal to cost dot size, and let's run the for loop from int. We are just running the for loop from second index, right? We are running the for loop from second index. So let's take int I is equal to 2 and I should be less than n and I plus plus. Let's update the cost with cost of I plus minimum of cost I minus 1 and cost of I minus 2. Right, at the end just return the minimum of last two, right? These last two, we are just returning the minimum out of this, right? So let's write minimum of cost n minus 1 and cost n minus 2, right? I hope this should work fine. Now let's just run it. Yeah, it's working fine. So let's just submit this. Yeah, it's working fine. So the time complexity of this approach is big O of n, and the space complexity of this approach is big O of 1, because we are just updating in place, right? We are just updating in place. We are not using any extra space for this, and the time complexity is big O of n because we are just traversing through the whole array, right? So I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.